wanted to kind of give you a little bit about why I love science. Okay, how it just, even when I was your age, just grabbed me and just really changed my life. And what I found when I was your age is that science was everywhere. It was in the way I threw a football. It was the reason that when I took a golf swing, the ball went out. Have you ever seen the balls go out and go like this? That's what all mine do. And science explained that. It explained to me things like tides. It explained to me rainbows, all kinds of cool things. And some people say that when you learn too much science about why things are happening, and that's really what was important to me, is why things were happening, that you lose the romance. You lose something. I don't buy that for a second. For me, it increases that. And what I found as I've gone on in science is that real, true science is way, way weirder than fiction. Okay? You couldn't dream up some of the things that are true. Like a rainbow. Who would have ever dreamt that one? Colors in the sky. Or, I'm a biologist, so I get completely just like, are you kidding me? When I start talking about genes and how that works. And oh, it's just, nobody could have come up with this. And then, like black holes. Would somebody have ever come up with the idea of a black hole? Have you ever heard of black holes? Yeah. You kidding me? So, what force is involved in a black hole? Anybody know? Yo!
The exploding of a star and the gravity pull creates a suction in space that can even suck in light and dimensions, and then it spits it out somewhere.
Did everybody hear that? Yeah. Well, it was awesome. Attaboy. So he explained it just perfectly, and I tell you what, I don't think anybody using creativity is going to come up with the idea that a star can implode and create a gravitational field so even light can't get out. So for me anyhow, the understanding of things makes things even more interesting and more, I hate to use the word romantic, but that's the word my wife told me to use. So, but before we can understand black holes, we really have to understand gravity. And that was my first experiment. And I could not believe what people used to think about gravity. Have you ever heard of Aristotle? Yeah. All right. Smart. No, he's a Greek fellow. Lived a while ago. Smart guy. He had this theory. He said that there's gas, there's water, and there's solids. And they have their natural place. Gases go up. Liquids go, water and liquids go on the surface of the solids, and the solids go down. And he kind of said that gravity had something to do with that. And then what he said was this. He said that if something has more mass than something else, like this versus this, that this will fall faster than this. Make sense? That's what he said. What he never did, and this bothers me a great deal. I hope I don't mar your floor. Okay? I think we're good. Okay? What he never did was that. Okay? Did this one here fall faster than the other one? No. Was it this? Yo! Okay. Okay, that's very good. The why that happens is actually way, way, way more complicated. I have some friends who are very good scientists, and they say, I don't really understand that. But we have some people here who might have better ideas. Go ahead.
Also, but that one has more wind resistance because it's wider.
Yeah.
And it's not
Okay. Yo.
Even though one may be larger than the other and have more mass, each of them has a center of mass or the same gravitational pull together.
Okay.
So even no matter what, if you do drop it, it will land at the same time because both of them do have mass. And technically, if something does have a solid weight of mass, it will fall straight to the ground.
Okay, good. Yo. Okay. That's awesome. The way that helped me do it, you guys are way smarter than I was when I was your age. The one thing that always helped me is this thing here weighs 50 times this. So if I had 50 of these all hooked up together with an invisible string, would it weigh the same as this? Yeah. Would each one of those masses fall at the same rate as this?
Yeah.
And for me, that helped a great deal. Didn't help Aristotle too much because he was dead wrong. The reason why he was dead wrong is because he saw things like this. He saw, you know, really light things, especially things that have a lot of air resistance, you know. There. What he didn't do was he didn't reduce the air resistance. So what do you think? Going to fall together, or is this one going to win the race again? You think?
Win the race.
About the same time? Okay. All right. So in order to understand black holes, we got to go back and understand a little bit about gravity. And that's a fairly simple question. There are others that are more difficult. These here are two pieces of limestone. I got these pieces of limestone along the shores of Lake Champlain up near Middlebury, a place called Button Bay and another place called Kingsland Bay. Limestones. Anyone know what kind of stone that is? Where it comes from? Yo!
I think it's rocks that have been compressed over heat and time for long exposures, and then the rock's gas bubbles inside expand, creating a different rock.
Almost. That would be marble. If you took the limestone and did that, you'd get marble. That's one of the reasons why we have a lot of marble around here, because there used to be a lot of limestone that got crushed and heated in that process. Limestone comes from seabeds. And in this limestone, there's little tiny imprints of animals that lived in that sea. Do you see that right there? Yeah. That there is an imprint of a little creature called a crinoid. We don't really have them anymore. There's a couple of other imprints. You can see an imprint right here. It's like of a little tiny shell. Do you see that? Yeah. These are sea creatures. Found where? Found in Lake Champlain. It's worse than that. They're tropical sea creatures. Where are the tropics? Yo! Yeah, like are we in the tropics here? Did you go outside the last few days? This is not the tropics. Yo!
The Earth's magnetic field has changed over the past 3.5 billion years, changing the climate of the entire world. So the tropics that were once here are now south.
Okay. Excellent. Has the climate changed here and there? Yep.
Yeah.
There's another reason, though. The land that you are standing on right now, 400 million years ago, was where Brazil is today. Where's Brazil? Way south. This land was down there. How'd it get up here? Well, these are some very difficult questions that are more difficult than gravity. Do you know how it got up here? Yeah. How many of you have heard of continental drift? Woohoo! Okay, good stuff. So as it came trucking up here, it brought the seabeds here, and that's why we have tropical creatures in stone in Middlebury. So once again, a more difficult one. When I was a kid, I was really lucky like you. I grew up in a very small and beautiful town. The town I grew up in was near the seacoast. So I had the ocean. You guys have the mountains. You know, which one do you like better? I don't know. You like, yeah, there you go. Yep. So some people would say mountains and some people would say seacoast. So one of the things that I learned is I learned how to sail. And you talk about science, there's all kinds of science in sailing. It's very cool. But one of the things that I'm going to try to do an experiment right here for you right now. And here's the question. So let's pretend that I'm on a ship, a sailing ship with huge masts. And I'm going to climb up to the top of the mast. Okay? And we're going to pretend that this thing here is the mast. And I'm standing on the mast. And I've got a cannonball. Okay? And I got a cannonball. This is not a cannonball. And I'm holding it like this. And the ship is under full sail. And we are cruising. So we are going this way, and we're going that way fast. And what I'm going to do is I'm going to drop this cannonball. Now I don't really want you to, what I want to do is I want to be able to prove what happens, but you might want to make a hypothesis. Everybody make a guess in their head. And here's what I'd like you to do. Is that cannonball going to land, if the boat is going this way, is it somehow going to land in front of the mast? While I drop it and I'm way up there, is the boat going to sail out from underneath the cannonball and this is going to land towards the stern? Or is this going to land right next to the mast? That's a hypothesis. We are going to try to prove that right now. You probably don't see a boat. Okay? So I'm going to kind of make a boat real fast. This. That's a boat. Here's the mast. I got to tell you, I forgot my stupid duct tape. You can never have too much duct tape. Okay, now, this thing here is going to represent my arm. Okay? And what I'm going to do is I'm going to take my cannonball. Here's my cannonball, and I'm going to hold it. Well, clearly, it drops straight down. Well, now what we're going to do is we're going to put our ship under sail. Okay. We've got a cord in the way. We're going to have to back up. Do you want to propel my sailboat?
Daniel already called it.
Danny! Danny's my assistant today. What's up, Danny? Not much. Okay, so we're going to back this baby up. Okay. All right, so, oh yeah, I'm liking this. It'll be better on this. Okay, so what Dan's going to do is he's going to get our boat sailing at a constant velocity. Do you all know what that means? No. All right. Okay. Not yet, Danny. Here's my cannonball. You like that?
Sorry.
And I'm going to put this right underneath the cannonball. Danny's going to get it moving fast enough so that, as I saw most people shaking their heads saying, what's going to happen, we're going to drop this, and the boat's going to sail out from underneath it, and it's going to land, in this case, on the floor. Okay? I don't think anybody's thought that it would somehow go this way. But there were a couple people who thought it might go straight down. We're about to conduct an experiment. Are you ready?
Yeah.
All right, Danny, get me a constant velocity. That's hold. What did it do?
Broke your boat.
Broke the boat. All right. Now, one more thing. If we were to have looked at that cannonball, would it have gone straight down or would it have gone like that?
Straight.
Would have gone like that. Does anyone know what that is called? Okay, gravity makes it fall. Why did it's called? Somebody said it right here. That's called inertia. Woohoo! An object in motion stays in motion. It was going that way, then gravity took over. But the motion in that direction kept on going. And that's why it made that path. Okay, thank you, Dan. It was awesome. And thank you guys very much for your attention. I had a great time. And good luck with the rest of your Science Summit. Thank you.